Good morning, guys of grade 8. Today, inshallah, we're going to start a lesson study of chapter 12. So, after we studied chapter 12, section 1 and 2, we understood what is chemical reaction and what are the steps of the chemical reaction, what are the signs of the chemical reaction, and last, or eventually, we studied the different types of the chemical reaction. So, today, we're going to talk about the changes of energy that are involved in a chemical reaction. So once we remember, just recall what we studied before, we know that any chemical reaction actually passes by three steps: breaking down of bonds and reactants, rearrangement of atoms, and formation of new bonds. These three steps actually involve a change of energy. That's why we find that one of the signs of a chemical reaction that there is a change of energy. So we're going to talk about this in details in that lesson. So let's find here what are our goals in that lesson. By the end of this lesson, we should be able to answer the following question: why do chemical reactions always involve a change in energy? What is the difference between an endothermic and an exothermic reaction? And what factors affect the rate of a chemical reaction? So here, guys, let's find our new vocabulary: endothermic, exothermic, activation energy, catalyst, and enzyme, and finally inhibitor. So let's see, guys. We know that, as we said, any chemical reaction happen in three steps. That's mean, okay, we need to break the bonds. So first of all, we need to know what is these bonds. Actually, the bonds, they are kind of force or kind of energy that hold the atoms together. Okay, so in a compound, okay, we find, or in any substance, the atoms of this substance are held together, or they are attached to each other by kind of attraction or kind of force that hold them. We call this a chemical bond. Actually, this chemical bond represents a certain type of energy, which is a chemical energy. So if we have two atoms, like let's see here, for example, if we have two atoms, these two atoms, they are just bonded to each other. They have this kind of bond, okay, here, which represent a certain amount of energy. So to be able to break this bond, or to just set this atom away, which is considered the first step in a chemical reaction, so we must apply a force or apply energy, which is more than this energy, to be able to break it down. So that means breaking down of bonds, it absorbs or require energy. The question is, from where does it get this energy? Okay, or it's from surroundings. What I mean by surroundings? Okay, I just a beaker, or I just have a tube that contain a certain substance. So what are surroundings that is gonna give it energy to break down the bonds? Actually, in this beaker, in this container, we have a lot of these substance. We have many atoms. They are holding to each other, and then so as they are in continuous motion, because as we know, the particles of a substance are in continuous motion, so these, due to this continuous motion, particles still collide to each other. So once the collisions, okay, are too much, they provide some kind of energy due to the friction and the kinetic energy of these particles. This energy will be at certain point enough to break down the bonds. In that case, okay, we find that the atoms set free, or they become away from each other. So at this part, we start the first, or like this, we did the first step of the chemical reaction. Okay, we get the atoms free from each other, or we break the bonds in the reactants. Later, or then we find that the atoms, they are gonna rearrange themselves. They are gonna have a new arrangement. This new arrangement, due to a new attraction or a new kind of force, will arise between these atoms. That means a new bond will be formed. That's to form the products. So this new bonds, it means another amount of energy will allow the atoms in the new arrangement to be hold together or attached to each other. So that's mean here, once the new bonds are formed, energy will be released to the surroundings, or this energy will be released in that case. Okay, so like this, we could find, as all chemical reactions, okay, have the step of breaking bonds in reactants and formation of new bonds in the products. Of course, the amount of energy which found in the reactants is not exactly the same amount of energy that found in the bonds of the product. So like this, all chemical reactions involve change in energy. Okay, because during breaking down of bonds, there are energies absorbed from surroundings. While once the bonds are are formed, there is energies released to surroundings, and of course, the amount of energy is not exactly the same. So like this, we have somehow changes in energy. So here we said we find that sometimes, or in that case, as we regarding to what we said, the amount of energy which is found in the bonds of the reactants may be less or more than the amount of energy which is already found in the bonds of the products. So regarding to this, we have two types of chemical reaction. First kind of chemical reaction, okay, That's a chemical reaction which its reactants does not have the amount or the required amount of energy to be able to produce the new bonds in the product. So in this case, this reaction will not happen, okay, unless it is get or unless it's supplied by more energy from external environment or from the surroundings. In that case, okay, we call this it's an endothermic reaction. It's a reaction that absorbs energy, needs more energy to be able to form the product. Okay, so here like this, okay, we find another kind of reaction that's already the energy which is stored in the bonds of the reactants is too much, so they are plenty of energy which is sufficient to produce the products, and we have extra, which means there are some energy will be released in the situation. Okay, so we call this an exothermic reaction. So to know more details about this, let's see here, guys. So first of all, we start by the endothermic reaction. What is endothermic reaction? Regarding to the graph, as you can see here, guys, you could observe simply that the amount of energy of reactants is too low compared to the amount of energy of the products. So like this, the energy which is stored in the bonds of the reactants is not sufficient or is not enough to be able to form the new bonds that will be for to make the products. So in that case, the reaction will not happen until this reaction absorbs energy from the surroundings. It needs extra energy. Like for example, in lab, we need the two chemical substances and add them together. They will not work until you heat them up. So you're heating, it means that you provide them with extra amount of energy, or by giving them an electric shock, or by shaking, okay, providing them with more kinetic energy that help them to form that product. So like this, that's examples how you provide energy for a chemical reaction. Let's take a real example in the nature. You know the photosynthesis reaction in which the plant makes on food. So the plants absorb carbon dioxide, water from the soil, and they start turn them into glucose. But actually, this reaction will never ever happen, okay, in the lab. That means if you just mix carbon dioxide with glucose, with sorry, with water, they will not provide, or you with glucose, or they will not produce. Why? Because actually the amount of energy which found in the bonds in carbon dioxide between carbon and oxygen, and the amount of energy which found in the bonds between hydrogen and oxygen in water, they are not sufficient to produce this high energetic bonds which found between carbon, hydrogen, and oxygen in glucose. So in that case, the reaction will not done. But once the plant is able to absorb the sunlight energy, it gets extra energy, which somehow charge the energy that found or the energy that is already needed to build the new bonds in the product. So like this, the reaction happens. So simply, we could say that the endothermic reaction is the reaction in which the energy in the reactants less than products. So like this, reactants will not be able to produce the products by their own. They must absorb or gain more energy from the surroundings. Okay. Here, the other type, which is the exothermic reaction. So what is exothermic reaction? It's completely the opposite of the endothermic. Here we could find that the energy of the reactants is too more compared to the energy of the products. That means the bonds already store or they have more amount of energy than the amount of energy required to form the new bonds in the product. So simply, once atoms set free, we have a large amount of energy, which is enough to allow the new arrangement of atoms to be held to each other, and the extra amount will be released. So that's mean here we have extra energy will be pumped to the surroundings in that case. Why? Because we know that the energy is conserved, it never be destroyed or created. So like this, for example, if the energy of the reactants is about 30 joules and the product's just gonna use about 10 joules, so we have extra 20 joules of energy. This 20 joules of energy will be just released to the environment or to the surroundings in whatever the shape of it could be, in form of light, form of sound, form of heat, and that the major type of the energy released during the chemical reaction. Okay. So here, guys, also we could observe something important. Okay, so which is the activation energy? What is me or what meant by the activation energy? So actually, we call that activation energy the amount of energy needed to start the chemical reaction. That means once we add chemical substances to each other, they don't just react at the moment. Okay, they just still take parts of seconds if the reaction is too fast, and if the reaction is slow, it may take more than this. Why? In that case, atoms need to gather sufficient amount of energy to be able to break the bonds between the reactants. So here we are going to find the activation energy. It represents the amount of energy that's collected, okay, from the reactants. So reactants here, the different substances you add to each other, they keep collide due to their collisions, okay. the energy start to increase, increase, increase. Once the energy reach a certain point, okay, that's here the highest amount of energy provided. In that case, bonds of the reactants start to broken. Once the bonds of reactants are broken, atoms become free, and that's what they start the new rearrangement to form the products. So like this here, we said that activation energy, it is the difference between the energy of reactants or the energy that's stored in the bonds of the reactants to the maximum point of energy or the maximum energy that we could gather due to the collision of the particles. So here, let's compare between the endothermic and the exothermic regarding to the amount of activation energy. First, we start by the endothermic reaction. In case of the endothermic reaction, we're going to find that reactants have too little amount of energy, which is not sufficient to make the product. So here, actually, collisions, okay, by their own or the collisions of the reactants together is not enough to break down the bond. In that case, we supposed to provide external form of energy, or we start to energize this reaction by adding energy. So this energy is absorbed from surroundings, okay, plus the collisions. Okay, so in that case, we're gonna find we reach the activation energy, and then the reaction will happen to form the products. So the difference between the amount of energy of products and the reactant that represent the energy absorbed. Okay, let's take an example, or to just make it in form of numbers. If we imagine that the energy of the reactants is about 10 joules and the energy of the products are about 30 joules. So like this, once the reactants already collide and break their bonds, they are gonna have just free, or they have about 10 joules only. That will not be sufficient to form the new bonds, because the new bonds requires 30 joules. So in that case, okay, we need to provide more energy. So we get here more energy. This energy that's by heating these reactants, or by exposing them to electric shock, or even by shaking, as we said, or something like that. So we're gonna find, okay, that the react in that case there is energy is absorbed. That means the amount of energy in products more than the amount of energy in reactants. While in the other hand, in the endothermic reaction, it's completely the opposite. Reactants already have a plenty of energy, so simple collisions between reactants are enough to break the bonds, okay? And once the bonds are broken, we have a lot of energy, which is sufficient to produce the products, and actually we have extra energy. This extra energy will be the energy released, and it will be released in form of usually heat. That's why we call them exothermic reaction, okay? So here like this, guys, we know what is the difference between exothermic reaction and endothermic reaction, and how energy changes during a chemical reaction. That's our lesson for today. Please study this part very well from your textbook, and if you have any question, I'm waiting for your questions. Thank you, guys, and goodbye.